everyone as an attendee is pretty aware. So this event will be recorded and it will be made available on our Process Industries Division YouTube playlist. And we can show this to you when there'll be a QR code at the end where you'll be able to kind of get connected to all our previous recorded events as well. We are going to mute everybody's microphones, etc., to help us run through for a smooth presentation. But we really do encourage you to ask questions. If you can put them in the chat tab, that would be great, because at the end of our session, after our speakers have spoken, we'd love to do a little bit of a kind of Q&A session to sort of pull up on some of your questions, and we'll do as many as we can in the time that allows. I'm going to now introduce our speakers. So we are very fortunate to have some talented people who know a lot about this subject of the circular economy and are sharing their understanding. We have Alan, who's a member of the Process Industries Board, but also has a wealth of background in sustainability and resources specialism. And Alan will introduce us to this topic area. We also have Simon Spooner, who is Associate Director at Atkins Realis and a Fellow for Water Quality and Carbon. We have Ian. Ian is not only the Chair of IMechE Process Industries Division Board, but also Vice President Sales at Bradley Pulverizer, and also the Chair of the Bulk Solids Handling Committee. And I am your sort of host, if you like, for today's session, and I chair the IMechE Pharmaceutical Committee. So excellent speakers with really good background. Simon with a great knowledge around water, Ian with a huge knowledge from bulk industries. And now we'll move to Alan, who will introduce us to this topic, something that feels very close to the vision for this group, which is treasuring our planet of future generations. So Alan, tell us a bit about the circular economy and help us understand some more.
Okay, thank you for that introduction. Well, I'm going to set the scene and explain why do we need a circular economy. I'll just look back in time. Between those two dates, 3 major events occurred on our planet. We discovered affordable sources of energy in coal and oil. We had an industrial revolution and our population rocketed, as did our ability to produce technologies, our GDP, the power produced, and our use of the planet's resources. And if we look into the future, we're destined to potentially have a population of 12 billion as opposed to 8. And we're already living outside what the planet can sustain, particularly with regard to greenhouse gases, the diversity of our animals, our land use, our water, our use of fertilizers, and our production of toxic materials. And we equally have put more carbon dioxide into the atmosphere, and that's caused our temperature to rise. And now 50% of our planet is put aside for growing food to feed us. And there is a view that we are at the start of the 6th mass extinction event. And since the Industrial Revolution, we have had a linear economy where we've taken materials, we made them something, we've used them, and then we've simply thrown them away, either into incineration or into landfill. And we still produced in 2023 2.1 billion tonnes of municipal waste. And this graph shows a country's development index against the number of planets it takes to provide that way of life. And for the 8 billion people to live the same is the average of the top 20 developed nations. I could ask you how many planets we need. Well, the answer is 3.6. And as you know, we don't have 3.6. So we really must start treasuring our planet. And we must start looking after all of the ecologies that we have. And we need a way of managing our home in a circular way, a circular economy. And this is particularly true with regard to carbon dioxide and greenhouse gases, the natural world, material resources, water, atmosphere, and population. And according to this report, we're actually going backwards, which is not good. So specifically, what do we need to do? Well, with regard to carbon dioxide and greenhouse gases, Well, we must get our carbon dioxide back in balance again. It was in balance for millions of years, and we've just destroyed that. So we need to deliver on our COP promises. We need to focus on all greenhouse gases and all sectors that make greenhouse gases. We need to develop a joined up plan to achieve it. And we really should try and get back to pre-industrial levels. As far as the natural world goes, well, we've got to stop its reduction and re-establish it if we can. And we've got to do that. We've got to deliver on our COP promises. As far as the material resources are concerned, we've got to start treasuring our material resources. And we've got to realise the planet's inorganic resources are finite, and they must certainly never be dispersed beyond the reach of future generations. And we should try and reduce consumption and think about the whole system when we design things. And we must try to produce no waste. Water, well, we've got to start treasuring and managing our water. We need nature-based solutions to help us solve the problems, but we must really stop trying to pollute our water. And globally, we must try and get the global ocean temperature to decrease. Atmosphere, well, we've got to stop polluting our air, and we've got to strive for clean air and clean technologies, including transport. As far as population is concerned, well, if we could provide a reasonable lifestyle for all and better education globally, then maybe the birth rate will equal to approximately the death rate. So we do need to have circular ecologies and a circular economy. Big question for you. Will we be able to sustain our current way of life in the future? Question mark. Is humankind doomed? Well, there are some people that would just rather, earn a lot of money and disregard the future, but the future has challenges. So we really need to start and act seriously now. Is it inevitable? Is there hope? Well, there were 3 moments when humankind achieved incredible things. In the Second World War, the United States increased its production of ships and planes fantastically, and we won a war. We did put a man on the moon, and we did generate a vaccine very quickly for a particularly nasty virus. We need the same mindset applied to living in harmony with our planet, provided we get on with it. Now, I believe there is hope. Thank you. Stop sharing.
I'll unmute. Shall I go ahead?
Simon, that's great. We can see your slides, so please tell us about water and the circular.
Okay. Yes. So as was introduced, I'm Simon Spooner. I work for Atkins Realis, big consultancy company in our water area, and doing water quality, water resources, and some sort of climate change related stuff. I'm somebody who's spent about half my career working internationally, mostly in China, so I sometimes have a different sort of a view of things, or used to doing things in different ways. What I want to introduce is actually trying to pick up on the hope side of what Alan was saying, and having a different way of looking at the situation we're in, and a bit more of a vision of where we could get to. I actually believe that it is possible, if we avoid the war bit, to create a much better world even than we have now. Right now, we're living in a golden age as far as human development goes, which may collapse or it may grow yet further. So I want to introduce this idea of combustion transition, which I'll explain a bit. The idea that what we really need to learn to do is how we flourish with nature, not dominate nature and take over the world, but work with it. I'm going to give some examples from energy and water, and the interrelationship between them, water energy. Particularly, I'll look at the concept of reversing the flow. It's a different way of looking at how we manage our entire water cycle, applying circular economy principles to that, and how that will work and interact with the energy and materials circular economies. I then want to pick particularly on the role of water in decarbonising buildings. These heating and cooling buildings is one of the biggest sources of emissions. It's sort of comparable with transport, sometimes depends on how you count. But there's really not much progress being made in decarbonising that, and we need a different approach. But all these different approaches also need to link together. We have to take a systems approach to how we change the different parts of us, how we make interventions and understand how they work, and particularly how we engage individuals and communities in this great sort of process of change and transition. So I will try and introduce this. Alan introduced it. Climate, biodiversity loss, pollution. Yeah, there's a problem. We've got net zero as our goal, which is a sort of well-established target, but it's one that's very, very hard to follow, to plan for, to know where we are. It kind of starts to slip away when you try and do the carbon accounting. It just all gets away from you. So I want to look at it in a slightly different way, in terms of thinking about where we live in the sort of biosphere of our planet, which is the combination of atmosphere, hydrosphere, lithosphere, ecosphere, the living systems. We're on a living planet. And what has this biosphere ever done for us, as they say? Well, basically, our equitable climate and atmosphere, they are because of life. There aren't other planets like it that we as yet know of, because it all requires life. Living things create a disequilibrium. You get oxygen into the atmosphere, reduced carbon on Earth, and then processes of respiration, balancing these gases, balancing a climate, balancing the planet. And that disequilibrium is what powers our life as well through respiration. As much as plants photosynthesize to create it, they also use that. And also that is what fire is. Fire is not a natural process, as it were, that you find anywhere else but planet Earth. You know, the sun is not fire, it's hot plasma. A volcano is not fire, it's just hot stuff. You need life to create that disequilibrium, and the collapse of that is fire. That's where, as humans, we learnt to use that to clear the land, to take control over nature and shape it to our will. When we enclosed the fire and put it into a combustion engine, that gave us the power to create our industrial society. The combustion engine sort of focuses that disequilibrium on work we want done. And now with fossil fuels, we are burning the past and the present life. Present life, you burn a bit of wood, you're burning present life. Coal, oil, gas, you're consuming what took hundreds of millions of years for the living system to put down. You're releasing all of the balance of atmosphere that represents, and you're consuming life. So we have to move away from that. So what does that look like? As I said at the beginning, we want to move towards our built environment working in harmony with the natural living things to obtain the services that we need. So every day we need services of warmth, shelter, water, nutrition, security, even beauty. These are things we get from the environment around us. And Alan was setting out how these can be sort of determined with the sustainability development goals. Those have to be delivered by people and organizations, and ultimately individuals, communities do the work to build it. So this is just sort of looking at how we can move away in our system. And I'll look at some of those elements, sort of the energy system, the water system. This is our sort of consumptive model that we have at the moment, going from the biosphere. We extract from that, we convert it into the materials that are convenient for us. We consume it in our cities. And where are we headed? Possibly not to a great future. And we need to change. And we need to switch on energy to the sort of circular infrastructure energy, where we're harvesting energy from the environment around us, not consuming from the living process that sustains us. Clearly wind, solar energy, these are very clearly sort of harvesting infrastructure energies, but so are some of the geothermal ones, taking the sort of deep nuclear energy from the planet. And nuclear energy itself is harvesting, some of the sort of ancient things which are left within the planet, and are essentially the infrastructure rather than consuming. The amount consumed is tiny. So what does this look like, this harvesting of energy? Most of it comes from the sun that is sustaining us. And what we have been doing is going through the middle, consuming the biosphere to get what we want to. And you might say we need to bypass it, either through the sort of renewables or through the nuclears, so that we get that energy that we need to drive our built environment. But we can also embrace the biosphere and work with it, and get what we need from working closely with the living system. And when we do that, we also often enhance the biosphere. Farming is basically enhancing the biosphere, creating fields, putting fertilizer on them, ploughing them up and down. We get far, far more out of it, but at the same time, we are destroying that system and damaging it. So we have to learn how to work more cooperatively as well. But the key thing on energy is that we have to move to bypassing that system, to not consuming the biosphere. That's the ultimate sort of test. I now want to move on to water, because this is what we're trying to look at today, in the context of that energy cycle. So I want to look at a different way. How do we actually have a circular water system? And maybe look at how we've managed our water in the past. So basically, we take from upstream areas. You make camp as an ancient person by the side of the river. You take the water from upstream, and then you throw your waste as near downstream as you can get away with, basically. And as we've urbanized, so we reach ever further upstream, up into the hills with our reservoirs, down into the ground to draw from deep aquifers. And we have to send our waste ever further downstream with longer pipes. Now we have to have sewage works to sort of extend that, pushing it away from us. We're sort of reaching out in these two directions. At the same time, we clear and plough the land for our agriculture, which destroys and damages the soils, which are our far biggest reservoir, by far the biggest reservoir in the UK. It's not a Thirlmere or something in the Lake Districts or the eland reservoirs of Wales I'm showing here. It's the soil underneath every field and every forest and everywhere that we are. And we've reduced the ability of those to retain and purify water. We've also, as living creatures, we're getting out of touch with that living ecosystem. We are designed to have a biome that works together with the environment around us, not always comfortably. If you are more in touch with the river, you're going to spend quite a bit of time feeling unwell, but ultimately it is what we're designed for. And our separation is also leading to a great many immune disorders and health issues, because we're too separated from that natural world. But also we've perverted that natural world so much that you maybe don't want to be in sink drinking the water from a river in England. That's really not going to do you any good, because it's not a healthy system that one can engage with. So how can we change that? How can we move from this current system, driving all the water down and drying it out the river, to actually taking the water from the bottom, from before it goes to the sea, treating it highly, supplying directly back to our cities. Then when we've used it, getting it almost as sterile as we can to go back into the river, so that we're not perverting the biome of the river. I mean, a wastewater treatment works is a wonderful living thing which we've enhanced and powered up. But what comes out at the end of it, it might be chemically, quite purified compared to what went in, but it has a totally different biome of viruses and fungi and bacteria that then affect the rivers and change the health of the system. So we need to sort of work out how we can keep that flow going, and allow the life to come into the river. So this is sort of looking through this process. Before, from the hills, the water runs down through natural environments. We have put in the farming, we have built the cities, we take the water from up in the hills, we put that into our cities, we put our waste in, we're also drawing out of the river, depleting the quality of the river is going up and down, and the volumes and depletion and pollution. And as we get further down, so it becomes ever more depleted. But we can do things a different way. It takes more energy, but if we take the water from the bottom of the system, treat it well, directly pass it upstream to our cities, releasing that back into the river, highly treated, that can then keep going down, we can have recirculating water, abundant water supplies, couple that with better soil management and healthier agriculture, and we can have a much more sustainable system. So I always say there's no such thing as a water shortage. There's just a shortage of energy, infrastructure, and organisation. We can learn to nurture those aquatic systems with us instead of consuming that whole system. This means higher levels of treatment, maybe sterilizing almost at the point of discharge to allow that life to come back. It's going to take a long time to get there. It's not an easy thing to do. But ultimately, this is a route to sustainable water, but it does need abundant, sustainable energy as well. This is circular economy. All circular economy is energy intensive because you're going against entropy, you're going against the system, you're having to reorder things. And so that needs more and more energy, which is going to have to compete with the other great needs of hydrogen and other circular economy aspects, which all need more energy. So this is not a quick fix, but ultimately we can have greater abundance of water, a system with healthier soils and recirculation, which would be far more resilient to climate, reduce flood risk because of the soil retaining more water, and we'd also be recovering the heat and materials from that water system and having a more healthy system. I'll give some examples of this, of how it has sort of progressed or is coming into being around the world. So first of all, I'll nip off overseas and we can look at Singapore. Now in Singapore, 40% of the water supply now is actually recycled wastewater, not direct into the pump into the system, but they take the wastewater, treat it to a very high degree, and then put it back into the reservoir. At the top, it runs down the river. They take that out, treat it again, and so more and more of that goes around. You have in more extreme sort of desert environments, such as Saudi Arabia, we're building this NEOM and the line and these ideas for sustainable cities in what is pretty much like the surface of Mars there. And there you're aiming for a 100% closed water cycle in those cases, where you're recovering all of the materials and minerals from that water cycle using a lot of solar energy, but you still need to have some natural systems in there. You've got to include some lakes and some sort of living elements to it, not just chemical works. And then back closer to home, if we look at East Anglia and the plans now for lowland reservoirs, though the Fenland Reservoir, which is sort of coming down sort of close to where the rivers become tidal, to be taking that water out, supplying Cambridge and further upstream, and reducing the load on the chalk aquifers and the chalk streams to try and improve and increase the abundance. This is now getting coupled with plans for greater levels of desalination as well. Desalination is kind of the extreme end member in this. There's an infinite supply of water in the ocean, but you need a lot of energy and a lot of infrastructure. So it's not the easiest thing to take forward. I then want to touch on decarbonising the built environment. So some 40% of our carbon emissions, 30 to 40%, depending on how you count, are from buildings, mostly in the UK from heating them. In other parts of the world, it'll come from cooling. The heating is quite difficult to decarbonise because fossil fuels are really convenient for heating buildings. And also our buildings have been built most of our existing buildings, all those Victorian houses with fireplaces, they're supposed to have a strong heat flux through them. The fires, your heating system, it's not just there to keep you warm, it also preserves the building. And if you just wrap everything in insulation and reduce the ventilation, you have big structural problems. So how do you supply that heat flux and enough energy without having to knock a building down and start again? How do you supply that energy? Because for a new building, it's quite easy. You can keep it all insulated, slap a couple of air pumps on it, and you're away. But for older buildings, and that's most of it, you need to get that heat flux in. And heat networks, moving heat around through water systems, are the way that one can do that. You can harvest solar thermal energy, which is incredibly, you just need a black pipe, basically. Send the water, warm water, down into the ground, to deep ground, store it in the summer, extract it with heat pumps in the winter. This is very different from district heating. In district heating, you need really properly hot water or steam going around, and then you use heat exchangers to extract that. But you can only run that really with a combustion source. Even combined heat and power, a modern power station, the waste heat is about 30 degrees or so. It's not very good. So you have to, district heating doesn't get you away from burning stuff. But a heat network with heat pumps can use basically lukewarm water at ambient temperatures, quite a lot of it, to move the heat around that you need. And this can become a new utility. And the great thing with heat networks is they don't have to be very big. It's not like you've got to create a national grid. You can do it in street by street, area by area. You can cross-link them. You can have different ownership models. Some could be privately owned or developer owned. You could have community, town ones, council owned, or just parish organisations, residents associations, or you could have big energy companies entering into this. So there's a lot of different ways you can combine all sorts of different sources of heat. You can combine that with cooling systems, which is going to become, as we feel today, become much more of a thing, and store that summer heat in the ground for the winter. So there's a huge change which we need to make in our system. And then the final thing, and I'm not going to have time to go into this in great detail, but is that all of these elements, that building heating system, that recirculating of all of the water around the system, around the rivers, the interaction with our agriculture and soils and flood risks, we've got systems with multiple components which are complicated, and we need to be able to understand how that interacts. And we need to take this systems framework approach. We need to understand what our system is, what is the outcome we're trying to provide. And I set that outcome earlier with this sort of flourishing with nature, so enabling people and nature to flourish together for generations. That's our sort of defined goal. And so what interventions do we need to take? What are the steps to get us there? How can we work our way towards that goal? And this is where I'm a consultant, so this is where we get into doing modeling and metrics and digital twins and all the clever stuff that we like to do as consultants and engineers and scientists and things. And I think there is very much a way forward on that. And it's about transforming our infrastructure, incorporating natural systems into it. And it could be looked at as two sort of groups of infrastructure. There's the networked infrastructure, the big stuff, the power grid, the water supply, all those sort of things, which we generally think of. But then there's all the local infrastructure, our own buildings, our gardens, the farmers' fields, the woodlands next to us. These also need to transform. It's the demand side. We need to be changing every boiler, every car, every vehicle, all this distributed stuff on the demand side. And our entire procurement and planning and infrastructure design system is not focused on that. It's all on the big stuff. And we need to create a whole new way of approaching the transition to so running to time. So I'll just summarize what I've been saying, which I hope made some sense, but I realize it could be a bit confusing. So basically, we're part of a living biosphere. That's what sustains us, and what powers us. It powers our bodies, and it powers our industrial society. We've got to work out how we stop consuming it, how to work as part of it, or where we're not working as part of it in a way where we're bypassing it. We're getting our energy and we're not messing with the living system. From a water perspective, we've stolen the flow of water from our rivers over the generations, and we need to learn how to put that back. With energy, infrastructure, organisation, we can put that flow and life back into the rivers, and they will return that with abundance for us. Water and energy, very closely linked in this. It's all part of that circular economy. You're trying to drive things in the opposite direction. That takes energy. It takes effort and organisation. It comes the biggest move we have yet to make in decarbonisation and moving towards net zero is that heating and cooling of our buildings. And we need to get the water systems as a part of that. And most of all, we need to engage people in that process of transformation. So that they feel part of those large-scale network things, your big rail project or your water transfer or your new road scheme or whatever. But also they need to be fully supported, funded and motivated to do their own local infrastructure and do the little changes that plug into those bigger schemes. And to understand how that works, you have to have a systems approach, understanding how the components work together, and then breaking down how the interventions you make will work you towards an outcome. Not all at once, this could take 100 years, but what is an effective step to go forward with? So I hope that made some sense, and it's maybe a slightly odd take on circular economy. But anyway, I shall hand on now. So to Ian. So I will stop sharing. Is that right? Yeah. And he will share.
Thank you very much, Simon. And good afternoon, everyone. We're following on from Simon's really interesting presentation. What is bulk materials? There we go, you can see me now. What is bulk materials? Bulk materials covers a wide range of industries and as such has a huge impact on the circular economy. We can be involved in anything from very small quantities of material in pharmaceuticals to slightly more in food, to the large quarries, ports, power stations, cement and fertiliser, just to name a few. So in my day job, we tend to be more involved in the large bulk industries that are seen to be the large polluting industries. So I'm going to talk primarily today about some of those. So what are we doing to move towards a circular economy? The short answer is not as much as we should be. What is being done is being driven through necessity, legislation, CO2 credits, the drive to be more efficient, but it's all being pushed rather than being embraced. Lack of availability of raw materials, Simon's touched on this. A lot of the materials used in bulk are quarried or mined. These are not infinite. We might think they are, but eventually they're going to run out. We have to treasure them and find other ways of using them. And political pressure. Political is politically seen to be good, to be treasuring our resources and the environment. So some companies are paying lip service to this, but not really taking it seriously. So the bulk industry's got a lot to learn. We are trailing behind many of the others. So I'm going to look at two case studies here in this. I'm going to start with one on the cement industry. Now, cement's a major construction material. It's used worldwide, and it is probably one of the most used materials on the planet. If you look at the cement industry, in 2023, we emitted 2.4 billion tonnes of CO2, which was 6% of the total emissions. If it was a country, it would be the fourth largest greenhouse gas producer. So what is the cement industry doing? They're looking at many things, but there in the picture there is a vertical mill. They've looked to move more towards efficient milling because it's a large power user. The old ball mills have become less of a feature, and you'll see more vertical mills, more efficient classifiers, and the drive to get their kilowatt per tonne down. But But that's just a small part of it. That's not the real core of it. So one of the things that's happening, people are embracing this new 7979 spec from British Standards, where they can add calcium carbonates or other pozzolans. With the calcium carbonate, you can go up to 20%. So that reduces your CO2 by 20% on your product. But calcium carbonate, limestone, it's a natural resource. We say it's plentiful, but it's not going to last forever. So we have to find other ways. We can't keep using new raw ingredients. So one of the other things that's being investigated, and there's a lot of research being done on, is to reuse cement. So how do you do that? Well, one of the ways is to pulverize the old cement down to a fine powder, add some moisture and heat, and quite typically direct the kiln exhaust back through there. That will help to absorb the CO2, and it will help to reduce the amount of greenhouse gases, and it will reactivate the cement. But there's limitations to that. You can't use it for high structural strength, and there's only so many times you can reactivate it. So there's further research needing for more work to be put into that, but it's not being looked at enough. The drive is more to add pozzolans and reduce their outputs. The other one I'm going to look at is the fertilizer industry. Now, the fertilizer industry is another large user of raw materials. It's also a large polluter. So the environmental impact of it is huge. Organic, industrial, domestic waste streams can dust and odour, energy, air emissions, packaging waste, and leaching in the soil. And leaching in the soil has been a big point of discussion in recent years with algae blooms in the rivers, which links into Simon's water earlier speak. So part of the fertilizer industry target is to reduce the amount of fertilizer being put on the land, and a lot of the major players in it now are offering surveys and support to the farmers in reducing their fertilizer coverage. But that's not all of it. So phosphorus, the P in fertilizer, is one of the main parts of the fertilizer that's used in worldwide. It's typically got from apatite rock, so that's very widely available at the moment, but high quality sources are getting less. You used to be able to get it at 36% of P2O5, so phosphorus. Now you're seeing 25% rocks as being good. You're also seeing the use of igneous rocks, which are harder to grind, so you use more power. So again, you're using more energy. And you're also seeing heavy metals in these rocks now. Heavy metals added to the soil is not good for the plants. It's also not good for the ecosystems, and it washes into rivers and adds more issues for the water. So what's being done? There's quite a bit of work being done on this, and reclamation of phosphorus from human sewage, animal bones, other carcasses is being undertaken quite intensely. There's one client of mine in Europe who's now producing a totally renewable phosphorus fertilizer, taken totally from using bones and human sewage. Now, there's various ways of doing it, but the most popular way is to precipitate the calcium phosphate out of the sewage, strengthen it to take the strength up, because as you can see there, typically sewage ash is 9 to 11% P. We're looking for 12 to 16p in a finished product as an ideal. So that's one solution, particularly for phosphorus. Another one is use of nitrogen. Nitrogen is a very high user of energy and high polluter. It typically uses a lot of fossil fuels to generate the nitrogen with the ammonia or urea. But again, there's a big drive to use chicken manure and other manures to give the nitrogen back to the soil. So we're seeing a big drive there. So quite a few users are now looking at a chicken manure sewage type MP fertilizer. There's not much advancement in the K fertilizers yet for going to a totally renewable NPK fertilizer, but there is a bit of work being done. However, there's more to it than just that with the fertilizer industry. Emissions are high. If you look at the pictures there, the one on the left, you can see a high level of stack emissions. You can tell that by the plume coming out the stack and going horizontally. The one on the right is a nice clean stack, very little emissions in there. The one on the left is what you usually see. You don't see very many like the one on the right. And this is something that needs to be improved. Stack emission tests are done infrequently in many places, and this means that the site does not look after it. It's a cost. So they want to do it, but they don't want the expense of it. The other thing is, when you've got stacks on fertilizer plants and scrubbers, you end up with waste. Now that waste typically has been dumped to lagoons to allow to evaporate, and then the waste solids have been disposed of in various manners. So it's all adding to what we're leaving behind on the planet. But what is starting to happen is there is a drive now to try and make a viable product from the waste streams that can be reused either into the main product or in an alternative way. So there is hope, but it's not moving as quickly as it should do. Emissions and waste streams are something that is low on the investment list quite often. So as an overview, a wider overview of it, bulk materials, a lot of our industries are big users, like the quarries, the fertilizer, the cement. So we're high power users. Because of that, we're high emitters of greenhouse gases. There is a drive to reduce it, high efficiency motors, more efficient ways of processing things, but it's being driven more by cost than a desire to support the planet. We have a poor public image, which we're doing nothing to help, really. We're seen as a dirty industry. People say cement, they say fertilizer. They see a dirty industry, polluting industry. And more what companies are doing is moving it away from developed Western countries to developing countries and hiding behind that, which isn't the answer. I know many major names who are just producing in low-cost developing countries so they can hide behind the pollution and emission situation. And that links into the emissions. Dust emissions are the biggest problem with bulk materials. It's not being handled properly. You go to most quarries or bulk ports, material handling ports, you will see dust. Dust is not being handled in the best way. That is all going into the atmosphere. It's wasted product, and it's also getting into water courses and other places it's not wanted. And then the final one, which isn't unique to us, but it is, we are a big user of it, is a lot of these rocks and materials that are used in bulk are shipped all around the world. We're burning biomass here in the UK, but that's shipped from Canadian forests. We're using rocks for fertilizer, for cement. A lot of that's brought in on big bulk tankers. Shipping these large volumes, and I mean really large volumes, hundreds of thousands of tons worldwide, cannot continue. We need to start using resources that are local and reusing what we've got. So globally, we need to reduce these. And on that note, I'm finished a little bit early, but I'm going to hand back to Claire with questions.
Thank you so much to Ian, to Simon, to Alan. I'm going to ask you to come back on with your cameras as our speakers, so we can pick up on that as we go through with the questions. We have a few in the chat that have already been asked, and a few other ones as well. One to start with that kind of came through with the Q&A is you've all talked about the preciousness of resources, whether that's our water, sort of all different elements in that way. How can engineers help raise the profile of these challenges and convince business leaders that this is the right thing to be investing in?
Shall I have a go at that?
Go for it, Alan. That would be great.
I think one of my points is the decision makers need to be given good information, so they base their assumptions on good facts. And if you look at scientists and engineers, we're good at that. We understand things. We tend to only talk about things we actually know about. So I think engineers have got a great role to play in informing society and informing politicians in the actual facts. So yeah, no, they can, but they've got to take part in it, and they've actually got to help facilitate that, and they've got to be part of the voice that says we need to do something different.
So very
That's
much
my view.
engage and bring our skills to the
Yeah.
forefront in our convincing
Right.
arguments. Any other thoughts on that one? Oh, sorry, Alan.
No, Simon.
Yeah. I mentioned at the beginning, I spent nearly half my career working in China, mostly on environmental policy for either the EU or the UK government, seconded into Chinese government. What I saw there was that a lot of the senior politicians are engineers and scientists, and that their policy development process is very much supported by their Academy of Sciences. And I would be brought in as a foreign international expert to sit on major policy development committees and things. So they will be looking around the world to see, well, how does everybody else do it? What works, what doesn't? And we would produce lots of explanations of that and clever things. Oh, well, this is how you have to do it. And they would read all of that and they'd look at it and then they'd do it completely differently. And they do it with Chinese characteristics because they have a very different administrative and political system. We may not understand. It's very hard as a foreigner to understand how that system works, but it does work. And it incorporates a lot of that engineering and science. And you see it now with their incredible transformation from, they industrialized in all the worst ways incredibly fast. And they are now reindustrializing to much more renewable and sustainable systems. I was responsible for water quality there and vast improvements in the quality of rivers and things, from absolutely horrendous to really quite nasty. But it's definitely, and they understand where they're going. So it is possible to do it. And there are places in the world that it is done. There are elements we might learn from that. And there's a lot of things which we probably don't want to learn from that. But it isn't hopeless. And these changes can happen if we get ourselves organised.
Absolutely. Thank you, Simon. Ian, anything to add from a bulk perspective? You talked about that push and pull and some of the regulations driving change, but is there convincing arguments engineers can make?
There is, but unfortunately, because of the way the politics is in Europe, especially Europe and UK, there is a drive to hide it in developing countries. So there's a lot of bulk material handling companies who are doing fertilizers and cement and other products that are doing it in developing countries where the regulations are lower and they're hiding behind another company name. So until there is a drive by government to actually hold them responsible for what is being imported, that's not going to change easily.
Okay, right. So a big barrier there when we're talking about moving to a circular economy. In the chat, go for it.
I was just going to say it's because we do hold the industry generally holds a bad reputation. Right. If you look back historically in the UK, the mining, the quarrying, it's got a bad reputation and it's not helping itself as an industry.
So some PR and communications I can hear from that part. Hey, there is a question I can see both Simon and Ian, you've started to add some flavour within the chat, but there was a question coming about how much benefit is there in using waste from sewage works to power sewage treatment works and any excess exported to the grid. You had some thoughts on this. Maybe Simon and Ian, you could just bring them to life because they're written in the chat. Would you like to talk first?
Yeah, Ian first, maybe.
Yeah.
Yeah, I mean, we've done work with phosphate extraction from sewage ash, and you can get energy from it. But as I won't step on Simon's toes, but Simon's exactly right in what he's saying. There is barriers with it, and the barriers for the P afterwards is typically you're seeing about an 8 or 9% phosphorus content after incineration, which doesn't give you a fertilizer that meets regulation levels for fertilizer production. So strengthening, increasing the strength of it is an issue. There is work being done, but precipitating the calcium phosphate out of the sewage allows you to strengthen it up and make a very pure phosphorus. But that process is complex and expensive. I'll let you fill in some gaps there, Simon.
Yeah. I mean, my main point is the slightly disappointing fact that the amount of energy available from sewage is less than we might hope it is. You know, it ain't going to power our world, and you know, it's quite difficult to extract, but it can be very useful. I mean, the sewage process itself consumes a lot of energy, so it's very good to extract that from it and at least use it locally. But it's not generally enough to be worth exporting into grids and things. But in terms of that P recovery, a lot of the other important elements to this are to do with the increasingly higher temperature thermal processes. It's like everything circular economy, you need to put more energy in to get your purified materials out. And if you use sort of higher temperature hydrothermal, high pressure processes on the sludge, sort of 250, 300 degrees or so high pressure, then you can get a much more concentrated liquor with the dissolved phosphorus in it. You can precipitate that out. I think it's as an apatite. I can't remember exactly the mineral it comes out of, but you can get a more concentrated and saleable phosphorus product that way. You can also separate yourself a bit more from any lingering heavy metals or nasty long-living chemicals that are often found in such, which is another problem with the recycling. I think there's going to be a huge move towards this in the not too distant future, because at the moment we don't worry about it, because actually we recycle all this phosphorus, all this nitrogen in the sludge by putting it on land. So it gets a bit of thermal treatment to sort of sanitize it, and then it goes onto land and we use it for growing crops. And there are problems related to this with the microplastics in there, with persistent chemicals. It's a good thing in many ways, but it's also possibly not the best thing to be doing. And we can see that getting faded out in some parts of Europe, some of the landers of Germany. It's already stopped. And I don't think it's going to carry on for that much longer. So then we're going to have to come up with a lot more process orientated means of extracting these minerals from our waste streams.
And I've been involved in some of that, and you're perfectly right with the process, but the actual process of it is quite expensive, which is one of the limits at the moment. A lot of work's being done in the Scandinavian countries on this, and I believe they're just starting to install one of the first working plants in Germany. So we watch this space. I think you're right, it's going to grow, but the cost of the plants has got to come down first.
Interesting. Often the case with start of technology, isn't it, that it's quite expensive and then people find a way. But sorry, Simon.
I was going to say you get it made in China. Well, one of the leading German pressure vessel based sludge treatment companies, the first thing they did a little pilot in Germany, and they were like, we're off to China because we need people who can build these vessels, because these are expensive stainless steel pressure vessels you need. And they just couldn't vaguely get it economic in Europe. So they were trying to get it done in China, but it's always difficult and a very slippery business. I don't think it fully succeeded in the end, but we tried for a while.
So we've got about 5 minutes left, and I just want to help kind of draw things to a close. There's quite a lot of interest in a comment coming through about use of waste heat in our industry and homes, and sort of seeing that to drive this, it really will need to come from government incentives or finding ways in planning constraints to sort of help encourage this to be included. Do you have any quick follow-up questions in this, follow-up points to this comment that's been put in our Q&A?
I mean, I'd certainly respond a bit. There's a comment there from Rich Campbell that circular solutions are almost always more expensive, which of course initially they are, and they always require more energy than just chucking stuff out your back porch. But it's it's the sustainability aspect. We can't keep going. We're building up costs, and those costs are growing, and they're increasingly biting. I mean, we feel it every day. We know it's happening, but we're still not quite there at really grasping the issues. The real change comes when you start to see these systems going into place, and suddenly they're not more expensive. I mean, some of the solar and wind sort of renewables aren't that much more expensive than the fossil solutions. They don't have those building negative costs. I drive electric cars. They are massively more efficient. They're generally better to drive, and most of the downsides to do with charging are fine. I can drive from one end of the country, no trouble at all. I'm fortunate I can charge it at home, sort of thing. But it's like there is possible to make that transition and to make a great leap in our efficiency. But we have to do it in a lot of other areas, and some other areas it is much harder. Decarbonising cement, as Ian was saying, that's a real tough challenge. But you can also look at that a bit differently. When it comes to decarbonising our industrial systems and all the high temperature processes where we use fossil fuels, we're very much going to have to move towards hydrogen as the only real alternative, as a low carbon means of doing that. And there's a lot of things we can then produce from hydrogen. We can produce steel using hydrogen. We can produce glass products, all sorts of things. We can also use it to create the sort of temperatures we need to make cement. And we can use hydrogen to make hydrocarbon fuels. So we can make synthetic airline fuel from carbon dioxide and hydrogen, and a bit of effort. But one of the critical things that's missing in that move towards having synthetic fuels is a really good supply of carbon dioxide, which is a bit counterintuitive. You think that's the whole problem. We've got far too much of it, but it's spread everywhere. And trying to get it out of the air, I mean, that's just hopelessly inefficient. And yet you've got the cement industry, which is there producing very high strength carbon dioxide all over the place. It's a bit distributed. But if you can bring the cement industry together with the synthetic fuels and hydrocarbons industry and the hydrogen and the renewable energies and nuclear and things into these big hubs, then that's when you're getting into the real circular economy system. So decarbonising cement, to me, is not just about reducing your cement use or using wood or timber. Well, we can have, yes, limestone is a limited resource, but it's not very limited. There is an awful lot of it. But the energy and the infrastructure to be able to use that, if we do it right, actually we can reduce that limit and make cement again a sort of a more abundant material. But it'll take a while and it'll cost a lot of effort.
I think you've given us the topic for another webinar, so I'm going to go close there.
Make one point, Claire.
Go for it, Alan.
Well, what we really need is our engineers to lobby government so that government put in legislation. Because if you assume corporates are going to do it out of goodwill or moral values, you're misguided, as Ian said. So we really do need informed people, like we've heard today, to actually lobby government and get government to make good legislation, put it in place to make all this happen, because it won't happen unless we do.
I think, Alan, you've just done a wonderful summary for us. I want to say, if I move us on in the slides, you can see where you can kind of download, and there are some QR codes that will be listed there, and we can sort of share them with you for extra information. But I will give you this in summary. Thank you so much to our speakers for sharing your process industry perspective on lessons and barriers in moving to a circular economy. I love, Alan, you talked about it, there's hope. and us as engineers lobbying, bringing forward for that legislation. I love where Simon, you're saying, how do we flourish with nature? And how do we really kind of stop stealing the water from our rivers? And I tell you what, Ian, with the case studies you shared, you really gave us actually, I'll circulate it back to there is hope, and there are certainly very many areas of industry where we can, as engineers, can be making a fabulous difference. If I move us on to the next slide, just to give you a heads up, so you know the date for one of our process industries up and coming webinars, which will be in September, looking at how the water industry uses valves, so giving you a bit of introduction to use of valves in the water industry. And if we just leave up the final slide, where please, by all means, give us some feedback using the QR code. We would absolutely love to hear from you, and please come and join us at the third of the fourth event in this series, which will be also later in the autumn, looking at other areas of process industry. So thank you very much, everybody, and I wish you a fantastic rest of the day, and thank you to our speakers.
Cool.
Thank you.
Okay, right. Thank you very much, everyone. I think